Welcome back to the Python Fundamentals series. Today we'll be talking about error handling. So error handling is the process of anticipating, detecting, and resolving errors in a program. Errors could occur due to many reasons such as invalid input, file not found, division by zero error, and so on. What error handling does is it allows you to reliably handle the errors without crashing your program. So Python provides several mechanisms for error handling. Today we'll be going through the try except block, the finally statement, and custom exceptions. So within Python, there are two types of errors. The first errors are syntax errors. These usually happen when you violate Python syntax rules, such as a missing colon in an if statement. The second type of error are exceptions. These usually happen during runtime when something goes wrong, such as dividing a number by zero or accessing a non-existent file. Let's begin talking about the try except block. So the try except block is used to catch and handle exceptions without breaking the program. The code inside the try block is executed, and if an exception happens, the except block is executed. So the basic syntax of a try except block is try, and inside the try block you put in your program, and the except block you want to first declare the exception type and then the code that's going to handle the exception. So let's have a look at an example of handling exceptions. First, we'll try to run this program without having a try except block, and we'll see that the program will run into an error and crash the program instead of printing out the last print statement. So here you see we ran into an error and the program crashes and exits. However, if we had a try except block, even though we ran into an error, the program will still continue running without crashing and print the last print statement. As you can see, we ran into a division error and we also continue running the program until the very end. So that's the usefulness of a try except block. It allows you to gracefully handle any errors without breaking or crashing the program. For a try except block, you can actually have multiple except blocks within one try except statement. This allows you to catch multiple different errors and handle each of them however you want. Here we see a try except block with two except statements. The first one is a value error and the second one is a division error. We have different except statements to handle different errors. If we first try input something that's not a number, we get the first except statement value error, and it prints out the error statement. And if we put in 0, we get the division error. Then we have the else block. The else block essentially executes if no exceptions occur within the try except statement and is used as a catch-all statement after all the exception has been passed. So here the same thing, we have the same try except statement, except now we have an else statement at the very end. So if we were to successfully pass all the errors, we'll print out the else statement. And there we go. Since 2 successfully passes all the except errors, we end up getting the final else statement, which is printing the result. We have the finally block we can use. So the finally block is always executed no matter what, regardless of whether an exception occurs. And here is just a simple diagram that I made just to give you a framework of how the try except block works. We can see we start off with going into a try block, and then we check whether an exception occurs. If it does, it'll go into the respective except block. If it doesn't, it will use the else block. And if we were to have a finally block, it will execute the block, and then it exits the try except statement. So here we have a program that is trying to read a file, and if the file doesn't exist, it will print out an error. We also have a finally statement which prints out that program is ending. This example is just to showcase that no matter what, whether we hit an error or not, the finally statement will always print. So in the first example, we have the file, so it reads out the file and prints out the program is ending. And if we were to change the file to a file that doesn't exist, we get the error, but we also still have the finally statement executed. You can raise your own exceptions manually by using the raise keyword, and this is quite useful for enforcing constraints or at times where the Python program doesn't pick up an error, you want to forcefully raise the error yourself. We have a function that is essentially getting the division of two numbers, and we want to first check whether the number is 0. And if it is, we want to raise it preemptively before returning the value. Once we have the function defined, we're going to have a try except block where we run the function, and if the function returns an error, we'll catch it with the except block and print out the error. So here we see the error was caught in the function and it raised into the except statement, and then we printed out the error. Whereas if we changed to a number that doesn't raise an error, the program will run fine. There's plenty of already built-in Python errors that you can use whenever you're handling exceptions, so be sure to check the official Python documentation, but you can also create your own custom exceptions. In order to create exceptions, you can create a new class that inherits from Python's built-in exception class. So let's go through an example of how to create a custom exception. In order to create a custom exception, we want to make a new class for the exception, and we want it to inherit the parent exception class that's built into Python. So first, we want to initialize the function by using the init statement, having self and message. The message could be whatever you want, and then we want to make sure to properly initialize the parent exception class by using a super function. And once we've created the exception, we can test it out. So here we have a try except block where it's asking for a positive number, and if the input is a negative number, we'll raise our custom exception that we just made. And there you go, we've successfully made a custom exception. So thank you for watching this video. Today you learned about how to handle exceptions in Python and creating your own custom exceptions. Thank you for watching the Python Fundamentals series. Like or subscribe if you appreciate these videos, and please stay tuned for more videos in this series.